Welcome back, Algebra 1B. How you doing? So, back to another lesson on polynomials. So today what we're going to be doing is we're going to be talking about adding and subtracting polynomials. So the big thing here, right, and actually we'll take a little brief detour off to the side of here, is that we're going to be basically just combining like terms. Right, so it might be worthwhile to take a quick second and think about what like terms are. So at the heart of it, right, like terms need to have two things in common. Right, so one of the things they need to have is they need to have the same variables. Right, so you can't add x plus y, right? If we were in class and I was like, hey, you over there, what's x plus y? You'd be like, I don't know. And you'd be right, because I don't know either, right? We can't add things if they're not the same variable. So you need to have the same variables, and I'm talking all of them. If you've got xy, you better be darn sure you're adding xy to it, right? You can't add xy plus x, right? They need to have all the same variables. The other thing that like terms need to have is they need to have the same exponents on those variables. And again, when we're talking about, let me just write up a quick example here, right? We were talking about xy plus another xy. If you have xy squared, like the squared is just on the y, you better be darn sure you got a squared on the other y, right? Or else they're not like terms. If you've got xy squared and x squared y, that's a no-go. Cannot do that, right? Because they don't have the same exponents on the same variables. All right, cool. So, like terms, brief recap there. That's basically what we're going to be doing to these when we're adding and subtracting them. All right, so our last thing we talked about was just about naming these, and now we're actually going to get down to business and do some stuff to them. So what we're going to do here, right, is I'm going to take a look and I'm saying, all right, trying to look for the like terms. So I'm noticing that I have a 2x squared. What I want to do is I want to take a look through the whole rest of the problem for anything else that's an x squared, right? Anything that should go with it. I'm like, oh, I got an x squared over here. And there's a 4, and then I'm also going to grab that minus sign that comes in front of it. That's going to be really important to us because, you don't just grab what's there. You also have to grab what it actually is doing, right? That is subtracting 4x squared. So that minus 4 sticks around with it. And after that, I'm going to move on to the next thing, right? I got a 5x. Looks like it should go pretty well together with that plus 6x later on. And again, on both of those, I grabbed the sign that came before it. Thirdly, I've got negative 7, and I've got 3. Right? So those are all our like terms, right? We've got everything all matched up and hunky-dory ready to go. Quick little thing before we get to the next chunk. Right? You might be asking yourself, like, what the heck's going on in front of this 2x squared? I'm glad you asked. Invisible voice. Right? What we're doing is we're saying, all right, that was a regular 2x squared, right? So regular old 2 is positive 2. Right? So it's kind of like there's a little plus in front of there. Right? Same thing with that 3 over on in the other set of parentheses, right? Currently, that's a positive 3. Right? So before we go ahead and squish these, right, we got to figure out what we're doing to them. So I'm looking at the symbol in the middle. That's telling me that I'm adding these together. So I got good news. When you're adding them together, you don't need to do anything fancy. Right? All I'm going to do is I'm just going to take the like terms and smush them together based on what it looks like I'm doing with them. So for that stuff in yellow, I've got 2x squared, and then I've got a minus 4x squared. So 2 minus 4 brings me down to negative 2x squareds. Right? You might be thinking to yourself like, well, why isn't it x to the fourth? Or why are there any x's at all if we subtracted them? Right, so the only thing that changes when we're adding and subtracting is the coefficient in the front, right? Because that's telling me how many of that thing I have. So what we were saying, basically, is that, oh, I've got 2 of this thing that I'm calling x squared. Right? And then, oh, later on, I'm taking away 4 of those x squareds. Right? So I'm not changing the fact that they're x squareds, I'm just changing how many of them I have. Right? So that's what we're doing. Next up, we got the stuff in the pink. Right, I've got a 5x, and then I'm adding another 6x. So if I had 5x's, and I add 6x's, I now have 11x. What the heck am I going to do with all those x's? Right, in the blue, I've got a negative 7, and then I'm adding 3. So negative 7 plus 3, negative 4. No big deal. Right? Numbers act just like normal. And that's it. Right? We made it through. Right? if you're trying to remember back to what we did last time around, I mentioned we were naming them. We would name this a quadratic trinomial, right? I'm naming it based on the degree, the biggest one of which is 2, and I'm basing it on the fact that there are 3 terms, which makes it a trinomial. Right, we're not going to dump too far into that, right? But something worth mentioning. That's how it connects to what we were doing before. Cool. Let's try another one out. For adding these polynomials, right, I'm going to start off the same way. I'm going to grab the like terms. So I've got this 5x squared. I've got this minus 3x squared. I've got this minus 3x and this regular old 6x, a plus 4, and a minus 3 that go together. Right? And again, before I start squishing anything, I gotta be careful about what sign's in the middle. Right? So always check that before you go too much further. This is a plus sign, so we're all set, right? Nothing funky's going on. We'll talk about what happens when you got a minus sign a little bit later on. So what we've got here, right, is I'm going to take the stuff in yellow. I had 5x squareds. I took away 3 of them. I've got 2x squareds left. Sweet. For the stuff in the pink, I had negative 3x's. I added 6 on, so I'm up to positive 3x's. Right, cool. I had plus 4 in blue, and then I'm subtracting 3 of it. So I just got 1 left. Cool, done. That's it. Alright, so something else we can do, right, because I know that you guys aren't going to all have like 18 different colors of highlighters and whatever else. So whenever you're doing these on paper, right, and you don't have a whole suite of colors up at the top there, right, is sometimes I like to put different little things underneath them to denote the like terms, right? So I'm looking at this one, I got 3x. I'm going to do them in red just so they stand out a little bit better, but you can do these in whatever color of something you're writing in. So I've got this 3x. I put a little squiggle under it. I'm going to put a little squiggle under the like term, minus 4x, that comes out a little bit later. When I've got x to the third, maybe I'll do a tiny little loop, right? Matches up with these other x to the thirds. I've got this minus 5 that maybe I'll underline twice. And I've got this plus 8 that I'll underline twice, right? So just like find some way of grabbing them all together. Some people I know also like to put little shapes around them, where it's like, oh, there's a 3x and there's a minus 4x, right? That works out fine. Sometimes it gets a little bit messy, so be a little careful with that, but whatever helps you identify the like terms and keep them together. So as we're going through this one, you might notice like, oh, I took care of all the terms in this first chunk over here. But there's still this 4x squared that we didn't do anything to, right? And that's okay, right? Sometimes you'll have terms that don't go with anything else. All we got to do is just make sure that we bring them down, right? We don't want to forget about them. So let's say that I did like a bunch of little downward lines like that. Right, cool. So then after that, it's the same old deal, right? I'm taking a look at that 3x, and then I'm subtracting 4x later. Whoops-a-daisy, I almost forgot. We're adding these, right? So no big worry there. So I'm taking the 3x way over at the beginning, and then I'm subtracting this 4x later on. So I had 3, I took away 4, I'm down to minus 1x. So sometimes you might not see the 1, right? It might just look like minus x. That's also fine, right? If you want the 1 there, put it there. If you don't, it's fine to leave it at. All right, so we have minus 1x. Then I'm taking a look at this x to the third and this plus 2x to the third, right? So I had 1 over here in the first chunk, right? There was 1 there. That's why we had it. So I had 1. I added 2 more on, so I've got plus 3x to the third. Right? We've got a minus 5 and a plus 8 that go together. So if I was at negative 5 and I'm adding 8, I've now jumped up to positive 3. And then again, we do not want to forget that we haven't taken care of that 4x squared yet. Right? So we're just going to say plus 4x squared on the end. So something we talked about during our last lesson was about standard form of a polynomial. So really what I should be doing here is I should be converting this to standard form when I write out my final answer. And again, all that means is that we're going to take the biggest power of the variable and write that one first, and then go to the next biggest, and then the next biggest, and all the way down. So what I'm looking at is that positive 3x to the third has the biggest power, so we'd write that one out first. I've got a plus 4x squared after that. I've got a minus 1x, and then I've got a regular old plus 3. All right, so this is really what we're looking for as our final answer. You know, it's not the absolute end of the world if you forget to do that, right? But really try to do that at the end of these problems, right? Make sure you're in standard form. Cool. So we'll kind of breeze right through this one, right? I'm going to go back to using the highlighters because I feel like it's a little bit easier for you guys to follow. Got some x to the fourths. We got these x's that go together. Got these regular old numbers. And then I've got kind of like the odd one out again. Right? We are going to be adding these. So what I've got in the yellow is I have an x to the fourth. I'm taking away 2x to the fourths. So I'm down to negative x to the fourth. I now have negative one of those if I wanted to put that one in. In the pink, I've got minus 3x and then plus 2x. So if I had minus 3 and I added 2, I'm up to negative 1x. Right, again, the 1 in front of the x is optional. With those numbers in the blue, if I had 7 and I took away 11, I'm down to negative 4. Right. And then last but not least, we got that plus 2x to the third that we have to add on so that we don't forget about it. All right, cool. So again, could leave our answer like that, but what we should try and make sure we're doing is putting them in standard form. Whoops, this thing might not cooperate. Oh gosh, it's really not happy with me. Let's try this out. Well, bam. Wow, look at me go. All right, cool. So if I wanted to write this in standard form, I would put that x to the fourth out in front. I would need to say plus 2x to the third after that. I would say minus x, and then minus 4. And then again, that's what we're looking for as our answer. All right, some of the writing might get a little funky because my tablet's getting real mad at me, but that's okay. We're going to keep on going. So down at the bottom of here is what we get when we're starting to subtract. When we're subtracting, we're going to start off exactly the same way. Right? I'm going to grab the like terms. So I've got this 3 and this negative 5. Got this minus 2x and this regular old 4x. Got this 2x squared and this 3x squared. All right, so again, before we go ahead and smush them together, we got to take a look at the symbol in the middle. Right? This time it's a minus. Because it's a minus, I got to be real careful. What this means is that everything in that second set of parentheses, right, everything that's over here, we're subtracting that from the earlier stuff. Right? So there's a couple different ways you could do these. One way is to kind of like say it out loud in your head as you're doing it, right? So what I would say, and we'll kind of do this like a little sing-along thing, like you got the little bouncing ball over the words at the bottom, is if I had 3 and then I'm subtracting negative 5, right, I could think about it that way, right? 3 minus negative 5 turns into plus 5, so it's 8. Right? But sometimes I find that people don't really like doing it that way. So the way that I like to do it instead is I'm going to take a look in the parentheses that come right after that symbol, right? So again, I'm taking a look at this chunk over here. What I'm going to do is I'm going to change all of these signs to their opposites. Right? So that 4x that was like a positive 4x is now a negative 4x. That minus 5, I now turned it into plus 5. And that plus 3x squared is now minus 3x squared. So what I did is I just applied that minus sign to each and every part of that. And now that I've done that, I don't want to use the minus again. So we're going to kind of cross it out and pretend that, like, you know, that's not there anymore. We used it. After that, now I can just go ahead and kind of do things as we did for adding. Right, I've got the 3 and now this newly plus 5 in yellow. So 3 plus 5 is 8. In the pink, now it looks like negative 2x minus another 4 x's. So I'm down to negative 6. Whoops. Negative 6 x's. Right, after that, we got 2x squared and then minus 3x squared. So I had 2, I took away 3, I'm down to negative x squared. Right. Whoops, let me kind of catch up with the highlighting there. Maybe make it a little bit easier to see what's going on. And again, what we should really do is we should write these out in standard form. So what I should turn this into is, oops, minus x squared. And then minus 6x. And then plus 8. All right, that's really what we should have our answer as. All right, cool. So from here on out, right, same kind of deal. I'm going to start off the same way. I'm going to grab the like terms. So we got those ones in yellow, Put these ones in pink. Got these x squareds in blue. Right, I've got another minus sign here. Right, so again, if you want to say it out loud in your head, that's fine. I find that sometimes I make more mistakes when I'm doing it that way, but if it works for you, go for it. I'm going to go ahead and I'm going to go in and change all of those symbols to their opposites. And now I've used up that minus sign in the middle, so we're kind of get rid of it. So now I've got 8x minus 12x in the yellow. So I had 8, I took away 12, I'm down to negative 4x. In the pink I have negative 10 minus another 7, brings me down to negative 17. And then in the blue I had 5x squareds, and I'm adding on another one, so that's plus 6x squareds. So again, nothing really too different than what we were doing on the last one, right? It's just a matter of being careful with that minus. After that, everything is the same. Again, if I'm writing it in standard form, I have 6x squared minus 4x minus 17. I would put that biggest power in front and then go down from there. All right, cool. 7, same kind of deal. We'll kind of run through this one as well. So again, grabbing the like terms, I've got these ones that have just a regular old x. We got this x to the third that doesn't have anybody to go with. Oh, that's so sad. That's okay, right? Just like before, we're just not going to forget about it. We got this minus 8 and this plus 2. And we've got this 3x squared over here. And so again, we're subtracting these. So everything that comes after that minus sign, I'm going to change it to its opposite sign. And we took care of that negative, so we're going to ditch it from the middle. And then again, it's just matching them up. Right, I got those like terms in yellow. I got 7x plus 9x. Gives me 16x, maybe. That worked better. Right. We have that 4x to the third that we don't want to forget about. So plus 4x to the third. We have negative 8 and then minus 2 in blue, so that's minus 10. And then the stuff in green is minus 3x squared. So again, nothing too different than the adding piece, except for taking care of the subtraction. But again, same thing as always. You're gonna get sick of hearing me say this. If I'm putting them in standard form, I got those x to the thirds out front. We got minus 3x squared up next. We got positive 16x's there, and then a minus 10 to finish things off. Right, taking that largest power and going down from there. Okay. Oh boy, what a doozy. Got this big one down here. So, I've got x to the thirds, go with x to the thirds. I've got x squareds, they go with the other x squareds. I got this x, doesn't have anybody else, so sad, oh gosh. But then I can grab those numbers together. Right, so again, same kind of deal. I've got the x to the thirds in yellow. Whoops-a-daisy, almost forgot again. Gotta grab that minus, gotta take care of that first. So I'm gonna go in and I'm gonna change all these symbols that come after it. And now we've used that up. So now this becomes a little bit better. We got 4x to the third and now plus 2x to the third. So I have 6x to the thirds already. Right. Stuff in the pink, right, I had minus 3x squareds, and then I'm taking another one away, right, because it's a minus. So I'm down to negative 4x squareds. In the blue, right, again, we don't want to forget about that 6x. Just bring it down to 6x, right? Nothing happened to it. Still hanging in there. The stuff in green, right, we got minus 4 and plus 2. So if I had negative 4 and I had 2, I'm up to negative 2. Oops. Good enough. And so hopefully the adding and subtracting doesn't seem that bad, right? All we're really doing is we're grabbing the like terms, we're smushing them together, sometimes being a little bit careful if there's a minus sign. And so, something we might run into is there are word problems, everybody's favorite thing. So, this example down here, we'll run through this one and then we are done. An electronics store is starting to track sales of cell phones and cameras. These equations represent the number of cell phones, P, and the number of cameras, C, sold in M months. All right, so there's a couple different things there, right? P is the number of phones, C is the number of cameras, and M is the months. Right? So if we were trying to write an equation for the monthly sales T of cell phones and cameras combined, right? The fact that they're saying combined there means that I'm going to be adding these. And so we want it to be T. Right? T is the total sales of everything. We say that T is equal to, I'm going to take the phones, the 7M plus 137, and then what I'm going to do with those phones is I'm then going to add on how many cameras I had. All right, so we'll say a plus, and then the number of cameras was 4M plus 78. Let me see if I can tidy this up a little bit for you guys. And the tablet's kind of getting mad the more I do this. Right. So same kind of deal, right? I'm grabbing the like terms. I got these M's that can smush together. I've got these regular old numbers that we can smush together. So then we're just going to do that, right? T is equal to, the stuff in the yellow is going to smush together to give us 11 M's. Right, and then the stuff in the pink, 137 plus 78 is 215. Cool. So the total number of sales, right, is 11M plus 215. What it wants us to do after that is we're actually going to use that, right? We're trying to predict the number of phones and cameras sold in 10 months. Right? So the fact that the 10 months is there, right, means that I'm going to use that. I'm going to say that M is equal to 10, and I'm going to plug that right in. So we're going to take the same thing we just had, right? T equals 11, maybe 11M plus 215. And I'm going to take that 10 and plug it in for the M. Right? I'm going to put it in parentheses so it doesn't look like 1,110. Right? When I do that out, right, all that's going to do is that's going to give me 325. Right, so that 11 times 10 is going to give me 110. 110 plus 215 is 325 there. And then we're done, right? 325 phones and cameras total. That's it, and I am out.